Let's look at another one. So here we can see that the domain, once again, is the set of components A, B, C, and D. The codomain is the set of all possible elements that we can map to. B, W, X, Y, and Z. Okay, the range, let's think about what elements are actually mapped to. Well, V is mapped to, W is mapped to, but X is not, right? There is no input that generates an output of X. There's an output Y and Z. So the range is V, W, Y, and Z. Is it a function? Well, does every input have exactly one arrow coming off of it? Does every input lead to an exact output? It does, right? F of A is V, F of B is W, F of C is Y, F of D is Z. So yes, it is a function. Is it on to? Well, easy way to look at this is every element in the codomain mapped to? Absolutely not, right? The codomain and the range are not the same. The codomain has one more element than is in the range, namely this value of X is not mapped to. Is it one-to-one? Well, does every element in the, and here's an important distinction, we're not saying every element in the codomain has to have one element in the domain. The definition of one-to-one means if every element in the range maps back to only exactly one element in the domain. So I'll just say not codomain. So if you're worried about, highlighted, underlined, not, worried about that element X and hey, it doesn't generate a single input, well, we're talking about the range leading back to exactly one element in the domain. So yeah, V back to A, W goes back to B, Y goes back to C, Z goes back to D. And so yes, this would be a one-to-one function. Another one here, okay, so domain A, B, C, and D, codomain V, W, X, Y. What's the range? Well, every output in the codomain has an arrow pointing to it, so the codomain is the same as the range, or the range is the same as the codomain. Is it a function? Yes, every element in the domain has exactly one arrow coming off of it. Is it on to? Well, yeah, the codomain equals the range. Is it one-to-one? Well, yes, it is, because every single output leads back to exactly one input. So yes, so this function is what we call a bijective. This is a bijective function. This is really convenient, namely if you think in terms of computer programming. Well, if I have a function that generates an output, let's say you give it a value of A and it outputs a value of X, then I could actually write an inverse function that takes that output and produces what the original input was. So think in terms of, for example, a person's social security number and the VIN number of, assuming they only have one vehicle, the VIN number of their vehicle. Well, every VIN number corresponds to one social security number. Every social security number corresponds to one VIN. Every social security number has a VIN. Every VIN has a social security number. It's a very convenient type of function to work with. That's why we like bijective functions. They just have these convenient features. If a function doesn't have one or more of these features, it doesn't mean it's not a valid function. It just means it's with it. Okay, now we've probably heard this terminology before. You've certainly worked with this in algebra. A function that is one-to-one is said to be invertible. For any given output B in the range, we can identify a unique corresponding input in the domain, little a. So in this case, in this example, if I have a domain, and I'll just focus on one element, and has an element of A, and this codomain has one element that we'll focus on, it's called B, then we know that to generate, given a value of A, what I would have to do is I'd have to input that value into my function, and it would output a value of B. But how would I take an element that I know is an output and figure out what its corresponding input was? Well, I'm going to write an inverse function that works the other way around, that basically inputs a value of B And I can't call that f anymore because f takes a value from the domain and maps it into the codomain. But an inverse function, which we write like this, f not to the -1, we want to read that as negative to the power of -1, but that's just a notation. You have to remember that's a notation, and that's a function that is inverting the inputs and outputs. So it inputs a value in the codomain and then generates a value back in the domain. So basically is a way of doing and undoing. If you think about it, addition and subtraction are inverse operations of each other. So if I give you a number, if I say pick a number, add 5 to it, and tell me what your number is, well, that's going to generate a unique result. Let's say your number was 6. 6 plus 5 is 11. You tell me 11, and I'm like, I can tell you your original number because it's a one-to-one relationship. I just have to subtract 5 from the number that you gave me, 11 minus 6. Hey, or 11 minus 5. Hey, your number was 6. And so that's the advantage of having a function that is one-to-one because it is invertible, meaning given an input, I can tell you what the output is and vice versa. All right, let's take a look at a couple more examples here. Here is one that we can see that the domain is A, B, D, and E. The codomain is 1, 2, 3, and 4. Okay, the range, the values that are actually mapped to are 1, 3, and 4. Is this a function? Well, it is actually not, right? Because check out element D. We say that element D is in the domain. D does not have exactly one output. If we just omitted D from the domain, then we would have a function, right? And for the most part, we specify our domain so that every element in our domain actually has an element in the codomain. So for example, we'll take a look at a function like 1 over x, and that algebraic function 1 over x is going to be undefined if you plug in an x value of 0. You have 1 over 0, which is undefined. Okay, but normally what we say for the function 1 over x is its domain is all real numbers except x equals 0. Okay, so if I were to omit that, well, we don't even need to worry about onto and one-to-one in this case, but let's say we omitted D. It would not be onto because we see the codomain and the range are not the same. Element 2 is not mapped to. And is it one-to-one? Well, no, it's not because the element 3 in the codomain, or in the range, excuse me, that element 3 has potentially 2 different inputs that generated it, and we can't determine which one it was with absolute certainty. So it's kind of like, let's say there's a John Smith, and that's the output, and the input is the person's social security number. So given a social security number, I can generate the name, the output, John Smith. But given John Smith, I can't figure out which social security number that person relates to back in the domain because there could be thousands of John Smiths in the world, and so, or millions even, who knows. So given just the name, I can't uniquely figure out their social security number like I can figuring out the name given just the person's social security number. That we can agree on, but the one-to-one would not be possible there.